logic is there. I like the approach you're taking because that's something they really value. Your pseudocode, walking through your edge cases, doing a dry run, identifying time and space complexity, potential optimizations. This is all great stuff.
Hey everyone, welcome back to another episode of Whiteboard Confidential. I'm Adam from interviewing.io, and today's episode drops us into a mock meta interview where our candidate tackles not one, but two binary tree problems. So what happens when you're staring at a tree question you've never seen before? The clock is ticking and every decision counts. You'll hear how the candidate worked through a deceptively tricky warm-up before hitting a classic recursion challenge that stumps even the most experienced engineers. This one's all about thinking on your feet, weighing trade-offs, and staying calm under pressure. Let's get into it.
I have a interview with Meta tomorrow. It's the initial phone screen. The format they mentioned was you basically solve two roughly leak code mediums in 45 minutes. So I just kind of want to benchmark against that to see, or even just get used to that type of formats. I have about 7 years of software engineering experience, mostly in backend infrastructure. So yeah, is there anything else that you need to know?
No, I think that's pretty good. I'm glad you mentioned the meta thing, so I'll try to give you something relevant. So why don't we do this? Let's do this. I'm going to paste this question. I want to see if you have seen this before.
Okay.
I have a little tougher, but that's fine. I'm going to go ahead and comment this out, and then here we go.
Given a root of this, I'm gonna read out. I'm gonna read it quietly. The depth of each node is the shortest distance. Return the smallest subtree such that it contains all the deepest nodes in the. Okay, it's called the deepest. It has the. Okay, I have not seen this problem before, so I'm happy to solve it and
Great.
start using my.
Before we solve this, though, It's great that you didn't see this before. So I'm actually going to do this real quick because I'm going to follow Meta's format. I'm going to give you another question while we get to that. That's going to be the follow-up. So here you go.
All right. Given a binary, find its minimum depth. The depth is the from the root down to the nearest leaf node. A leaf node is no children. Okay. I'm ready to start talking and working through this problem with you. If this is the format, which I think it is. So to me, this is feels like a pretty straightforward problem. When I'm thinking about trees, I can think about BFS, DFS. We're looking for the minimum depth number of nodes along the shortest path from the root to the leaf node. So if I have a tree that is like this, sorry for the formatting. The minimum depth. Okay, so in this case, the minimum depth would be 2, right? Because there's 3 and 2. And if I add one more, this would be the minimum depth would be 3. Is that understanding correct?
Yep.
Cool. Finding the minimum depth, I guess one approach is to basically find the depth or traverse the entire tree, keeping track of depth and have a separate variable keeping track of minimum depth. So what that would look like is, let's do 5 So if I have this tree, I can just do BFS, DFS. I look at the 3. Min def as we initialize it to something really high or something. And I start with the 3. I look at the 1. I look at the 2. And as I'm going down, I'm incrementing. I'm keeping track of the depth. And when I see 3, 2 is a leaf node, I will compare it to the current minimum depth and see if it's either none or smaller. In this case, it's none, so it's going to be 3. I go back, and I go back to 4, and I see that this is 4. I see that the depth is still 3, so nothing changes. I go to my right subtree, and I go down here, I see the depth is 2, and I convert this to 2. So, and then when I fully traverse the tree, I explored every depth at each leaf node, and therefore I'm able to determine the minimum depth. So that is one of
that approach that you just mentioned. Which one is that? Is that BFS or DFS?
Oh, when I walked through it, I was using DFS. So, so I go down, and then so a BFS approach would be, so one of the things I was thinking about while I was walking through this is there something we can do is there something special about the minimum versus maximum? Like if we can traverse the tree such that we find the minimum first, then the first leaf node we find could be the answer, and we won't have to traverse the tree. Whereas maximum, for example, if I see 5 here, and I know that the left side is not a leaf node, but the right side is, then I kind of know that I don't have to keep going, because the further I go down, the answer is definitely going to be longer. So that makes me more inclined to do a BFS approach. BFS, traverse each level. If there is a leaf node, we know that it is the minimum depth, because we defined the depth as the shortest path from the root down to the nearest leaf node. So the nearest leaf node can be explored via BFS. Yeah, so I feel like the worst case here is still equivalent to the DFS, but on average case, especially for the pretty lopsided, unbalanced trees, I can expect this to be more performant than the DFS approach. Do you have any questions so far?
No, I think those are 2 approaches that are both solid, but I do think BFS might be slightly better in some cases.
That's how I feel on the average case, especially when the trees are not well balanced, basically.
So,
yeah. Cool. Is it okay if I code this up, or is there any other questions you may have?
Please, yeah.
Okay, I'm going to start with writing the node. Or should I write this boilerplate? I know with Meta they mentioned you don't let you run the code, so do you think I should write the boilerplate, or should I just skip it?
You should write it. Let's adhere to OOP practices, right?
Adhere to what practice?
Object-oriented programming, right?
Oh yeah. Okay. And so with BFS, I usually do it by do it by creating I usually traverse it by using a queue. So I'm going to create a deck. Here that's how you pronounce it, even though it stands for double-ended queue. And I should also probably check for the case in which root is not exists, in which case I will probably return 0 or some predefined thing. So while q, I'm going to iterate and pop off the node is equal to q.pop left. And if the node is a leaf node, so if not left and node, not node dot right, it's a leaf node, in which case we can return our dep, which we haven't instantiated. And then otherwise we will queue our sorry, I made a mistake here. I need to traverse level by level, so I'm going to write a for loop here, which traverses through each level. So this one will be the first level, and then and then if not, then if no dot left, append no dot left, and then if q no dot right, q dot append no dot right. And then for each time we increase the depth by 1, I feel like there's a risk I have a off by 1 error here with the depth. So I'm just gonna and I don't think this will end. I don't think this while loop will end without reaching some kind of leaf node. So I'm just gonna raise an exception just in case. Except, oops, sorry. Assumption. Cool. Let's see here. Okay, I'm gonna run through this with the example that we talked about. By hand. Super ugly. This is what it looks like. And this is right now. So my q starts off with debris, and my depth is equal to 1. So for n in length q, I pop this off, and this condition, line 46, is not true, so I don't return depth. I see I have a left and right node, 1 and 5. So once I finish that, my depth will become 2. And now I pop off the 1. The 1 here is not a leaf node. It has 2 children. So I add 2. I add 2 and 4 to my cube because they both exist. And then I go to my second index in this array, which is the 5. I see 5 has no children, and I return depth, which is 2. And 2 matches what I expect here, which I'm happy about. And we can talk about potentially edge cases, but is there any questions you have so far?
Nope, I think you solved it, and you definitely walked through it. This is the perfect format, so this is what Meta will do. They're not going to let you run the code, at least since I remember. But
yeah,
you talked about everything. You gave 2 different approaches. You went with more the optimal one. I would only say, what is the time and space complexity of the BFS approach?
The BFS approach on average performs better because for trees that can be imbalanced, it will basically return early. It'll find the first leaf node. But the worst case is still you have to traverse through every node. And this is what happened in the case of a perfectly balanced tree. So, okay. Which is the same as the DFS. So, which is O of n, what n the number of nodes.
Right. What about the space complexity?
Space complexity is also O of n because we're keeping track of the queue here. So the queue could basically enqueue, if it's a fully formed tree, this could be up to, some constant of or some portion of the total number of nodes. So
awesome. Okay. Well, here's the follow-up question. Question 2.
The depth of each node is sorted to the root. The depth of each node. Okay, that's just what we know so far. The deepest. So instead of the minimum, it's deepest. That's maximum. The node is called the deepest if it has the largest. A subtree of a node is a tree consisting of that node plus all descendants of that node. Okay. There's a lot to keep track of, so I find it most helpful to just work through some examples. So I'm just gonna copy what we have before that we built. I'm familiar with that. So the input is a root. The output is the node, the smallest subtree. So it's the node of the, tree that contains all deepest node. Okay. So let's look at this example here. The deepest nodes here are 2 and 4. We can figure that out if we just did one of the DFS BFS approach by keeping track of the depth. Unlike the I'm just thinking out loud here. If I know for minimum trees, minimum depth, we have the optimization traversing in depth sorted order. And I'm wondering if maximum depth has a similar thing. That's just something I'm gonna table for now because I'd rather get the correct solution first. So, at least for the example, we have 2 and 4 being the deepest nodes. So once we have the deepest nodes, contains all the deepest nodes in the original tree. So deepest nodes is maximum length or maximum depth of nodes, and all the depth of all depth of nodes are the same. So in this case, this deepest node in this tree at 2, 4, what we would want to return is the 1, right? Because the 1 contains both of them. If we expand this tree such that the 4 has a right child, then this example would become 6. And then what would the answer here be? Would it be 6? Is that how I'm understanding? Because it's the deepest node.
Well, all the deepest nodes would be, I think in this case it might be 4 and 6, right?
Oh, 6 is a right child of 4. So
right, and because 6 is the deepest node, and it needs to have a parent, right? Because we're looking for the tree.
Oh, right. We're not considering 6 to be a parent of itself, right? At least not a subtree of itself, basically.
Yeah.
So. Okay. That makes sense.
You wouldn't return 4. You would return 4 and 6, right? Because trying to return the smallest subtree.
Return the smallest subtree. I assume the output is a pointer to the node of the subtree, so it would be the 4.
Technically, yes. Let's assume. You're right. It could be a pointer. I just gotten so used to returning in an array format, but it could be a pointer. Totally fine. Yeah.
Okay. Okay. Yeah. Let's do that. The array thing, I'm not as used to. Let's just do that. We can maybe workshop this later if we decide.
Don't worry. If we've defined the expected output, this is fine. Yeah, as long as you in the weird tree, I think we're fine.
Okay, that's fair. So I think I understand the problem. Let's just do one more. If the 7 here of the right and 8 is the right, then the subtree would be, we would return 3. Is that correct? This would be, the deepest nodes would be 8.
Technically, this is where things get a bit hairy, right? So we wouldn't return just 3. We'd have to return 3, 1, 4, 6, and 3, 5, 7, 8, and we wouldn't return the 2 as part of that, right? So as another follow-up to this, instead of just returning the root, try to print out the pick your choice. I'd say print out the in order traverse like array of the root of the smallest subtree. Well, even then, that would include the 2.
Sorry, you mentioned like... 2. Oh, there's 2 here?
Yeah, because I'm trying to make this bearable because we have limited time. But the trick is you'd have to return. Oh, actually, no, it's fine. Just return the root. Yeah, it's fine.
Okay. Yeah, it feels a little bit trickier to return the path. Okay. I'll think about this afterwards too, but I feel most... yeah. Let's do that. Okay. So to me, I think I understand the problem clearly. There might be other stuff I'm missing, but let's talk about approaches. So to me, at least when I walk through the example, it seems like there's 2 parts. The first part is find the deepest nodes, and then for the deepest nodes, find the what they call it, the lowest common ancestor, or lowest common parent. Parent ancestor is probably the right word. So to find the deepest nodes, we traverse the tree. This is kind of from part 1. DFS the tree. Keep track of deepest nodes via a list. And yeah. And then for deepest nodes, for each node, this might be a bit trickier. So if I have 6 and 8, how do I keep track? How do I find the common parent? I guess I could just traverse for each, since they're the same depth, and they are same depth, traverse each one parent up at a time. And if the parents are all equal, return that parent. I know in the first part we didn't add a we have left and right but not parent. Is it okay to add a parent, or should I try to work with the exact same class that we did in part 1?
Let's assume that we're not going to be able to have parents. We're just going to have value left and right on each node, just like we've done.
Okay. Got it. Okay, let's work. Let's try to work with that. So if I can't traverse up, that means I'd have to find each element on the way down. So that doesn't sound super efficient, because the naive approach is for each element. Let's see. I guess I would have to do the recursion. Find recurse left and recurse right. And then this recursion function starting at root function takes in a node and returns if all nodes are in subtree. So if, oops, not all nodes, some nodes are in subtree. So we can do some casework here. So if left subtree, if the recursion is true and right is false, then we know that the subtree, the answer subtree, is on the left side. Because if the right subtree doesn't have any nodes, that means doesn't have any of the deepest nodes, then we know all the nodes are on the left subtree, and therefore we're like the current node is not the answer. It's in the left subtree. And vice versa, symmetrically, if this were reversed, if this right subtree was false, was true, and the left subtree was false, then we would have the symmetrical answer. If left subtree equals true and right subtree is equal to true, then we know that we are the answer, the subtree with the deepest nodes. Does that make sense?
Yeah, I think I understand your recursive approach.
Okay. I'm trying to decide if I want to. I have a good sense that this will lead to a correct solution, and I could either walk through it manually to try to get to it, or do you feel like we should try to optimize it before we try to
Definitely
talk about
do not optimize before coming to a solution. Don't prematurely optimize.
Okay. In that case, let's walk through this approach, at least with the English approach, and see if we reach our solution here. So, let's start with step 1. Find the deepest nodes. So we can do that with DFS. We'll keep track of a list, deepest nodes, deepest or max depth is equal to 0 or 1, and then deepest nodes is a trick. So then we start with 3. 3 here is 0 actually. 3 here is it's not a leaf node, but we can keep track of the depth. Equals 0. Max depth is equal to 0 or 1 or whatever. We can do DFS. It shouldn't matter too much. So 1, let's do pre-order 1 and then 2. 2 is a leaf node. Now we're at 3. This max depth is 0, so we did this to 3, and then we set this to 2. Now we go down to the 4. 4 is not a leaf node. 6 is a leaf node. So 6 becomes 6 as 4 greater than 3, the current depth. Yes, it is. We updated to 4. Since we updated the depth, let's restart the list to be 6. Then we go up, blah, 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 3, 5, 7, 8. 8 here is depth 4. The max depth is 4. It's equal to the max depth, so we can append the 6, the 8. Now we traverse.
What if you didn't have the 8 or you just had the 7?
If you had the 7 here, the depth would reach 3. So the depth is 3. The max depth is still 4. And since the depth is not greater than the max depth, or not greater or equal to the max depth, we don't do anything. So the deepest node would be 6.
Okay. But technically, trying to think in this case. I guess it shouldn't matter. Yeah, you're right, because the root would be returned as 3 in that case, right? Or actually, no,
it'd be 4.
6. Yeah, you're right. No, that's fine. I apologize. Just wanted to confirm that edge case.
Oh no worries. Happy to answer any questions. I'm kind of flying by to see my pants as well, so we'll see if it's actually a good solution. And this would be a very interesting case too, because when I wrote this approach in the first place, I had assumed there'd be more than one deepest node, and I haven't really thought through the case in which there would be 2. So we can write a little note here to little edge case note. Edge case, 1 deepest node. Okay. Let's see. And let's stick with the original one with 6 and 8. And let's look at the second part. For the deepest nodes, find the lowest common ancestor. So for this, I'm actually going to do it with the tree structure. So we're going to do the question mark. So basically, I'm going to try to mimic traverse a tree with the calls here. So let's see. So with the calls, I'm going to do a pre-order call stack. Let's see if that works. So recurse starting on root node, find deepest node in the subtree. The answer is find the lowest common ancestor. Recurse last time the root. The function is some of the deepest nodes are in the subtree. So if I'm at the 2 here, I see that it's not the subtree, so this would be a no. Let's do false. And I go down here, and this would be we're not sure. Then we go down further. Is this a deepest node? This is yes. So this would be a true. That means this would be a true. And that means this would be a true. And that means then we go to the right subtree. This is a I don't know. This is I don't know. This is a true because 8 is the deepest node. That makes this a true because one of the subtrees is 0. And this is true. And since both of these are true, we know that 3 is the answer. So we note it somewhere. Answer is equal to 3. And this will return true as well. So that's kind of how I think about this. Let's work through the edge case of only one deepest node because that's a pretty interesting case here. We assume that there's, more than one. The thing I'm thinking is one a generalizable edge case or is it strictly an edge case? Is it indicative of a pattern of edge cases or is it just specifically one? And if it were 3, then that would be edge case 1 deepest node.
I think it's an edge. It's not like a or anything. I mean,
yeah. If it's just 1, then I'm just thinking that if it's 1, then I can just try to find its parent and just return that and use a separate logic. It doesn't seem...
Because what's the ultimate thing this problem is trying to solve? It's trying to find the lowest common ancestor of all the deepest nodes. If your only deepest node is the 6, the only common ancestor of the 6 is the 4, right?
Right. Yeah. So I'm trying to rectify it with the approach here, which assumes that some of the nodes are because the condition for setting an answer to be true, setting an answer is if there are nodes on one side and nodes on the other side. But if that decision boundary, if that decision condition doesn't apply for one, then it's gonna fail. Does that make sense? So, maybe I can account for it by saying that if there's only one, if there's a left but not a right, or there's a right not a left, then you are the answer. So, okay, I think
the issue is with well, I will. Do you need a hint? I can try to give you a hint.
Yeah, sure. I feel like
Normal fair. So the issue, I think, is in the case where you have, let's say, the 6 and the 8, right? Those two are both of the same max depth, right? I think there has to be a definitive max depth, and then you disregard anything else that isn't of that max depth value in terms of the deepest nodes. That makes sense. And then that way you can focus on the LCA.
Yeah, that's definitely very helpful. I'm just trying to think of the implication of the. So basically, you're saying we know the depth of the deepest nodes. It's going to be 4. So if we see a node that is 3, then we can ignore it. But how's that going to help me? I guess to me, the confusion is like, how's that going to help me find the. So, like in the edge case of one deepest node, then you're saying like just find the node with depth -1, basically.
Basically, yeah. Like if you had a parent property, you would basically return its parent, right? But so we don't, kind of craft your algorithm in a way around it, which you're trying to do with recursion.
Yeah. Exactly. That makes sense. Is equal to deepest node. Yeah, maybe I'm getting ahead of myself here because I'm trying to think of the case where there are 3 deepest nodes.
There could be infinite number of deepest nodes depending on how tall the tree's height is, right? I mean, technically, you can have a complete binary tree of height like 100, and then at level 100 you have all the leaf nodes, right? And they're all deep.
Yeah. I'm deciding whether my recursion is sufficiently like I can cover one deepest node with my approach. I don't know if I can cover 3. I haven't really worked it out because when I wrote this approach, I was in my head I was only thinking about really 2 deep nodes, which is not not the smartest thing to do. So yeah, I'm just thinking if I should try to find a different approach, or should I try to work this recursion approach, and try to make it work for 3+ deepest nodes, like more than 2, because I know for 2 it would work. So yeah, I think it makes sense, but I'm not. Yeah, maybe we can walk through the example here. Let's do 9. Let's say 9 is the right subtree of the right child of 4. So we'll do.
And by the way, we have 10 minutes.
Okay. That's thanks for the note. Cool. So what would this look like? This would be this, true. This would be a true. This would be. Yeah, I don't think this approach works because if I go to the right subtree, the 6 would be a true, and then the approach would say this is a true and this is the answer because of my condition. is that the answer is if the left and right subtrees recursion calls are both true, then you are the answer. And that doesn't seem right to me. We could keep track of a count of max nodes seen. And we can increment as we traverse through it. But that seems prone to be buggy as well. So
why don't you calculate the max depth before even like tracking the leak nodes? So you know what I mean? Like get the max depth in a separate function and then use that max depth as you're trying to find the subtree, and then that find subtree would have your recursive logic. If that makes sense.
Can you repeat that? I kind of, you said, I know max depth, find the max depth.
Yeah, that should be your first step. And that should be a function in and of itself. And then secondly, you want to have a separate function that actually finds a subtree and then passing your max depth as a parameter of that function, if that makes sense. And you could also track the current depth. So that way you never go past the max depth. If you ever reach the maximum depth at the current depth in your recursion, you just return the current node, if that makes sense. Or
return the current node. Maybe you can help me understand with the example here, because I know how to track the max depth, right? It would be 4 at the bottom here. How could 4 help me reach an answer where I end up at 3, which is not anywhere near the bottom? Is kind of what I'm asking myself.
Is it will hop off the recursion, off the call stack, right? And then eventually it's going to check the left and the right. And if both left and right are true, then you return that current node, the root, right?
Yeah.
If left exists, then you only return left. If right exists, you only return right. And this kind of goes with recursion. Because you had, the idea is kind of there. Like you had the logic essentially, but I think you just needed to short circuit with the max depth.
Oh, wait. Short circuit.
And just track the current depth. I don't know if this helped you or not. I mean, hopefully this hint helps.
Track the current depth. Short circuit the max depth. I'm trying to understand, because you can't go deeper than a max depth. So how you can't go deeper than max depth. So if you're tracking a depth, like what would the short circuit condition be? Because if you can't, sorry, can you repeat that? I cannot hear you.
Depth equals max depth. That's your base case, I guess.
Mm-hmm.
Then you would return the root that you passed into the recursive function. That's your base case.
Yeah, no, that makes sense. It would be the same as saying, like, if it's a leaf node, right? I guess not, because it could yeah.
Exactly. So with the leaf node, you wouldn't return the root. You'd have to return, I guess, like none. It's Python.
Yeah.
So the value in recursion, right? And again, I guess
okay,
it is a leaf you're passing. The pointer would be none anyway. Never mind.
Okay. So what would that look like? So if I'm just walking through the example. If I'm at the depth, this would be a 9. This would be a 9. This would be a 6. This would be a 6. Or Is this kind of what you're saying here? And what would this thing, if you have left and right, then would this be a 6 or a 9 or a 6, 9?
It would be its root, right? Because each level or each thing has recursive call, so it would be its root.
Got it. So this would be 2.
Definitely not a chain of
and yeah. Okay. And if this were a 4, then this would return none. Or none. And then would this still return 1? I guess it would still return 1. This 5 here. This would be 7 and then 8.
So why would the 4 be a none?
Oh, sorry. I was not thinking about that. I was actually trying to think of. I jumped ahead of myself. Think about the edge case of if I was trying to create an edge case in which not edge case. I was trying to create a situation in which a leaf node is not the deepest, so I can work throughout the logic of how would that affect the decision of what to return here at the one.
Yeah, then 4 would be none. That's right. Or rather, 4 would if there's no leaf, yes, it would return none, and then you'd compare the recursive call from 2 and 4. It'd be true and false, right? Left would be true, right would be false. Because left is true, you would return the left subtree, which would then pop back up to the 1 with a truthy value, right?
Mm-hmm.
And then potentially all the way back up to 3.
Okay. That makes sense. Okay. For the sake of time, I could either try to code this or if you need more
like.
Sorry?
I'll give you an extra 5 minutes if you'd like. But that's the most I do. Just simply so it.
Okay. Wait, sorry?
Don't worry, you have until 7:55. I'll give you extra time. I just have to put at the end for questions, just like they would.
Yeah. Let's do xdef is going to be root. We talked about def is equal to 0. Max def f equal to none. Deepest nodes. And then for stack is equal to root, while stack nodes equal to stack.pop. I'm just writing the boilerplate. Node stack.append code.right code.left.
In the future, you really quickly boilerplate up above members. You can copy that just for reference.
Oh yeah, good. No, that was BFS though. I don't know if that's the same. But I guess it doesn't super matter. Yeah. Depth. I need to keep track of the depth. F is 1. This is 1. I want this to be def plus 1. Def plus 1. Oops. And this would be node depth. If depth is greater than max. Depth. Max depth equal to depth. And then deepest nodes is equal to node, and then LF depth is equal to max depth. Append node. Else don't do anything. What's this? Not happy. Cannot be assigned to object. We ignore that for now. And then for lowest common ancestor, root nodes. The base case we said is depth if the root node, the depth, max depth is equal to max depth, and return node. You want to return the current node. And we want to recurse the left. Left is LCA. Node dot left. Depth plus 1. Max depth. Right is equal to LTA. So we got right. Depth plus 1. Max depth. We want to check here if left and right. Return node. If LF. Actually, we can just return LF return. If one is the other, it should be L or right. Otherwise, return none. And then if not node, return none. And then our thing are
Sure about that?
left or right? Is that what you're saying?
I don't think that's. Let me see. What's the other function you're creating? I'm curious.
Oh, this is the overall function where I call LCA. This is the max LCA of deepest nodes. And then max nodes is equal to maximum or not max depth, but return max nodes or deepest nodes. So I want deepest nodes equals to max depth root and LCA root. I guess I want to return the depth. So maybe I return the depth here. And then max depth. One max. I didn't want to overshadow, that's why I wrote def and def. And
well, what if your root is null? Would the depth be 1?
No, it'd be 0, but I can check for that.
Perfect.
Okay. Yeah, well, I know we're at time, so I don't want to spend more time, but this is the high level picture of what I would write. So
I'm going to share with you one thing, and we can kind of jump into the review aspect of things.
Okay.
So this is not going to be in Python, but it's very similar. I mean, tomato. So this is what I was referring to. Like, I think you did solve it. I'd have to run it to see, just because this part on line 156, 157 is a bit iffy for me right now. Because once you have your max depth, right, and that's your base case, what you want to do with your recursive is basically just pass in your root.left or the current node.left, the current depth, right, plus 1 because you're going down, and and the max step, and same thing with the right side, right? And basically, the value you have from that, like from the overall end recursion, right? It would check to see if left and right are, if they're not falsy, right? Basically, if the deepest leave is in the left and also the right, right?
Right.
It return root. Otherwise, it's not an else if. It checks an if the left, then you return the left. If the right, then you turn the right. And that's kind of the logic you want to do here. The or would not necessarily result in the right answer, if that makes sense. Because if you have left or right, you're returning node first and foremost. You're not returning the calculation of the recursion or the value from the recursion, which is left and right. You'd want to return either left or right. You'd only return node if it's left and right. If that makes sense.
Yeah. That makes sense. Yeah, I'll have to walk this through later because what we wrote in the and we walked through the example. I was returning on line 109, 110. I was indicates if the 4 was a no, I was returning 1 instead of 2. I was just following that logic without thinking too much about it. So you're saying, yeah, I'll have to walk that through again. But like in terms of translating what we talked about to code, that was kind of how I translated it. So
for sure. So I will essentially start giving you feedback now because I think it's worthwhile. You're basically there. Meta is very strict. Unfortunately, I mean very, very strict.
yeah.
So in this case, technically, I wouldn't like advance you. Usually, what happens is if you solve 1 out of 2, they kind of like, especially if you're almost there with the second problem, they might consider moving you forward. It's more of like a, depending on like your work history, your experience, all that kind of stuff. But if you don't solve at least 1 out of 2, it's definitely no. In this case, you did solve 1 out of 2. I don't know your context, your resume, your experience, and all that, and the kind of position you're applying to. But generally speaking, assuming just like a general viewpoint, since you didn't solve the second one correctly, I wouldn't move you forward. Although it's a technical screen, right? If it's not like an actual on-site round, if it's just a technical screen, I would potentially move you forward. So I want to make sure you have that context. Technical screen round, you pass, but on-site round, you definitely wouldn't like. This wouldn't be a positive interview for an on-site round interview, if that makes sense.
Yeah, no, understood.
But yeah, I mean, your logic is there. I like the approach you're taking because that's something they really value. Your pseudocode, walking through your edge cases, doing a dry run, trying to find what's wrong with your logic or what's right, identifying time and space complexity, potential optimizations, asking whether or not if you have time or should consider pre-optimizing something, right? Or if you can just kind of go into it with the original approach that you've already identified. This is all great stuff. What else can I offer you? Be very cognizant with the time, unfortunately, with Meta. I hate this. I hate how they do this. Makes no sense. But yeah, they are going to be very, very like strict at the time. So when it comes to intros, when it comes to all that stuff, just, like have your thing kind of memorize in a sense to just quickly talk about your stuff and not spend too much time on it. Don't try to make too much small talk with them. And I think with Meta, what they actually try to do is they do try to offer hints and everything. At least my experience when I interviewed Meta, they are very much so. It's like, they're engaged and they're trying to solve the problem with you. It's not just like, hey, here's the problem. They're just going to keep quiet and see you struggle or see you succeed or something, right? So ask questions, communicate, talk. Don't just think things through your mind. Do what you did here today, right? And I think hopefully you should be fine. I mean, this is one of those like weird questions where it's worded weirdly, right, on purpose. So, I mean, just be ready for that too. But I mean, you identified an LCA approach, which is essentially what this problem is. So, yeah, I think you'll be fine. Technical screen, you'll be fine.
Okay, I appreciate it. It's a technical screen. A quick question. You are usually they say 2 questions. Are the 2 questions usually related the same way you like laid it out? Where they kind of
no. Unfortunately for me, I remember when I interviewed Netta, this was only about a year and a half ago. Actually, no, I'm sorry. It was yeah, it was a year and a half ago. I apologize. So what happened was they gave me they literally gave me a binary search tree question, like do a level order traversal and print out the array of that traversal, I guess. And then the second question was a algebra type map question. I guess because they were trying to jump on the AI bandwagon, and they just asked me a random math question that I just couldn't remember. I didn't know how to solve it at all. So, and that was a technical screen round. But for whatever reason, I didn't pass. Just simply because I guess the algebra thing wasn't there. So they can literally throw a math question at you, or they can do something like I did, where I've had that happen to me as well, where they, built upon a question, like similar pattern, similar data structures. So unfortunately, the answer is it depends.
Okay, that's fine. I appreciate the data point.
Yeah. Any other questions? Maybe I can offer more insight.
No, I think it's. I mean, just it's a good feedback loop when you don't finish the question. So, I definitely have the feedback I'm looking for. Yeah.
Awesome. Well, I do wish you luck. Keep practicing. I think you're there. At least for technical screen, I think you'll be fine, but just really keep grinding for the onsite.
Cool. Awesome. Thank you. I appreciate that.
All right, that's all we have for today. Thank you for watching. And if you want to get immediate feedback from the same people who make hiring decisions at companies like Google, Meta, and OpenAI, hit the link in our show notes to book your session now.